A continuous function is a function that has no holes, jumps, or vertical asymptotes. You could draw it without lifting your pen from paper. The intermediate value theorem. If a continuous function with an interval a, b as its domain takes values f of a and f of b at each end of the interval, then it also takes any value between f of a and f of b between some point within the interval. The normal line. The normal line to a curve at a particular point is the line through that point and perpendicular to the tangent. To find the left-hand limit of a function at a point, plug numbers that are 0.01 to 0.0001 less than the x value. The negative value lets us know that it approaches negative infinity. What is the relationship between a function and its end behavior model? The coefficient determines if the graph starts negatively or positively. The greatest degree is how many changes of sign there are. Vertical, horizontal, and slant asymptotes may be found from the function. To find the horizontal asymptote of a function, look at the highest degree in the numerator and the denominator. If the numerator is less than the denominators, the horizontal asymptote is at 0. If the numerator equals the denominator, then the horizontal asymptote is the coefficient of the numerator over the denominators. If the numerator is greater than the denominator, there is no horizontal asymptote, but there is an oblique asymptote. What is a jump discontinuity? A jump discontinuity is when a y value seems to jump from one connected piece of the graph to another. To find f of a plus h for the function negative x to the fourth power plus 3x minus 1, plug in a plus h into all the x values. Distribute the negative. Factor the polynomial 20x squared minus 23x plus 6.
Okay, so it says find a value a so that the function f of x equals 3 minus x squared when x is less than negative 1, and when ax squared minus 1 when x is greater than or equal to negative 1 is continuous. So first what you would have to do is set both functions equal to each other. Right? and then plug in a -1 for x. And just solve. So 3 minus 1 equals 1a minus 1. 2 equals a minus 1 plus 1 on both sides. And a equals 3. Alright, so here it says the equation for free fall on Earth is s equals -4.9 t squared feet, where t is in seconds. Assume a rock is dropped from a 60-foot cliff. Find the speed of the rock at t equals 2 seconds. So our equation is s equals -4.9 t squared. And to find the speed, we first have to find the velocity, and the velocity is the derivative of the s, which is s prime equals 2 times -4.9 t, and s prime would equal -9.8 t. Plug in 2 seconds, and you would get -19.6 feet per second. Now when you're finding speed, it's actually the absolute value of your velocity. So the speed is 19.6 feet per second. Now for number 12, determine the limit when x goes towards pi of 3 cosine x minus sine x plus 2 by substitution. So find the limit as x goes towards pi of 3 cosine x minus sine x plus 2. Plug in pi for x, so the limit x goes towards pi of 3 cosine of pi minus sine of pi plus 2, which equals the limit x goes towards pi. And the cosine of pi is just -1, so it would be 3 times a -1 minus the sine of pi, which is just 0, plus 2. Limit as x goes towards pi is a -3 plus 2. The limit as x goes towards pi is a -1. Now here we have to find the limit as x goes towards -infinity of the absolute value of 8x plus 6 over 4x minus 2. And what you have to do here is divide every single number by x. 8x over x plus 6 over x over 4x over x minus 2 over x. Now we assume that these values would just be 0 because their values are extremely small, so they would just go towards 0. These x's would cancel out, and you end up with the absolute value of 8 over 4, and you get an answer of 2. Here, assume the limit f of x as x goes towards a equals -1, and the limit g of x as x goes towards a is 3. Find the value of the limit as x goes towards a of f of x times g of x. Now this is super simple. You do the limit as x goes towards a of f of x times g of x, which is just -1 times 3, which is -3.
Okay, for this problem, you want to find the vertical asymptote To do that, you want to set the denominator to 0. And you want to solve for x. X will go plus or minus 2. It's only going to be plus 2 for this one because you put a negative 2 right here, it's going to be a 0. Can't have that. I already drew the graph over here, put in the graphing calculator. You only find that it's 1 right here, as I said before. And now it says describe the behavior. Well, on the left side, it's going to go to positive infinity. And on the right side, it's going to go to negative. Now you want to expand this while distributing that negative. So you'll come out with, let's see. Sorry if it's blurry. This cancels out with that. So you'll be left with now you want to distribute the delta x. These cancel out. This is basically 0, so you're left with f of negative x. Negative 4x, and then you want to plug in your 3, negative 12. For B, your answer is find an equation for the tangent line. To do that, you want to put 3 in for this right here, so it'll be negative 2, 3 squared plus 1. That'll come out to negative 17. So the equation will be y plus 17 equals negative 12, which is the slope you got from the last problem, x minus 3. And that's your tangent line. Alright, for this problem that says power function and behavior, what we want to do is divide everything by the highest exponent, which is x cubed. So I'll do that now. X cubed over x cubed minus 2x over x cubed plus 3x over x cubed minus 1 over x cubed. And you have to do that to the denominator as well. Over x cubed plus 5x over x cubed. This will turn into 1. That goes to 0, that goes to 0, that goes to 0. This is 4, that goes to 0. So you'll be left with 1 over 4. Okay, for B, it says find the horizontal asymptotes. You plug it into your calculator, you get something like this, which is at 1 over 4, which you got over here. The reason why there's not a negative 1 over 4 here, because negative over negative is going to be a positive, so you're still only going to be left with 1 over 4. So that's why it's like this. And your only horizontal asymptote is going to be 1 over 4.